Remora. What they eat, I don't know what they eat actually. I don't know. And then we have other freshwater fish in the river. This is a hitch, which can get quite big, but normally here they're only about 1 inch long. They're little tiny ones. They're little forage fish.
So they're so like a steelhead trout may eat them.
Is that
could yes?
Yeah, so like a 3-inch steelhead trout.
Trout could eat a 1 inch hitch. Yes.
Is that a steelhead?
Yeah, that's a drawing, so it's not totally representative, but it's a male steelhead. See that hook of the jaw? That's a male steelhead.
So the males, they're kind of like.
So they have like a hook on the jaw.
Yeah, even like the regular salmon, they have a bit of a hook on the jaw.
Yeah, because I know like sometimes in salmon.
Not as much as other salmon.
Yeah, because some salmon get like big hooks.
Right.
Yes, some salmon.
Chum salmon and pink salmon get big hooks. So those would be males, and this would be female because she doesn't quite have the mouth shape. Yeah.
And looks like little different coloring.
Then we got these two. These are stickleback. They're cute little fish, but they have little spines on their back, so nobody eats them because guess what happens when you eat them?
Poison?
No, all those spines stick out and they're hard to eat.
Oh.
So
What if you
things
cut
to eat
them
them.
off though?
Well, the other fish can't do that. They don't have a tool like us. So. And they have scales too that are kind of stiff. So most fish
bite their
don't.
head off.
Yeah.
And then
Well, like
the
the skunks and different things like that have bigger mouths eat them, but the other fish and the frogs don't mess with them.
How? We read somewhere that Cal-Am in the Steel Association are working together to make like the rescues that they do to make them unnecessary.
Well, that's the goal. Yeah, I don't know what the steelheaders are doing. The district is working to try and support Cal-Am getting a new water project so we all minimize our water from the river to make the rescues unnecessary. The steelheaders primarily work in the tributaries to the river. So where's that map I gave you?
Here.
Yeah. So they primarily work like in Hitchcock Creek and Garza's Creek and Robinson and Potrero, those ones there, and then especially up in Cashawa Creek, this one here. Now, Cal-Am does not have any wells in those areas, so when those creeks, when the main river goes dry from here to the Carmel Valley Village, that's where Cal-Am has pumps. So Cal-Am is 80% of the water pumped in this area is pumped by Cal-Am. 20% is pumped by private people with small wells. But about 80% is pumped by Cal-Am. But in all the tributaries, those are private people with private wells drying up those creeks. It has nothing to do with California American Water's operations. So even when Cal-Am gets off the river here and we have the desal plant up the coast, right, and the river is running here, is more wet, that's not going to change what's happening in the tributaries. That's a completely separate problem. That has nothing to do with Cal-Am.
Can you tell me the different spawning areas in this, in the different areas?
I'll try and print you guys off a map here if you got time. Depends how quick you got to leave. But they make it up into these areas here, partway up the two forks of the main stem. They make it into Cashawa Creek, about that far up, into the bottom of Finch Creek and a little bit up this tributary. Tulositos Creek, maybe in ancient history used to have steelhead in it, but it's really dry. If you guys have ever driven all the way out Carmel Valley Road to try and go over to Greenfield, this is a very dry grassland area. The river flows very quickly for a very short time in the winter when it's raining hard, then it goes dry. So it's not likely that there were that many steelhead up in Tulositos Creek. But there were steelhead in all these creeks along here.
So like mostly on this side?
Yeah, mostly on the south side, right? They're on the north side of the basin. On the south side of the basin is where they were because the south side has what? North-facing slopes? And so north, when something faces north in this part of the world, is it hotter or cooler? Cooler, yeah. The south-facing slopes face the sun. So all of these creeks are on south-facing slopes, so they're getting more sun. It's drier. They dry up quicker. These are on north-facing slopes, so they stay wet longer.
So most of them on this side.
Yeah, and mostly in the bottom half of all those ones on the south side. And I can get you a map that has dots on it that shows the upper limit of the spawning.
Wait, so like under here?
Right. Yeah. Everything. So like, if you took a line and went like that, so everything south of that line.
So like.
Yeah, kind of like that, right?
That?
Yeah, kind of like that.
Everything under this line.
Yeah.
Is where they're
So like over here.
Right. And they can be in here in wet years, but it takes a really wet year because think about it. It has to rain enough to open the lagoon. They got to swim up here. It then has to have enough water for them to get up into this creek. It then has to stay wet long enough for them to spawn and make a nest. Then it takes about 45 days for those eggs to pop out and start swimming. So, and then they can't swim very well for a few weeks until they grow bigger. So this has to stay wet months, right, in order for them to have a full life cycle there. It usually stays wet doesn't stay wet that long. It stays wet a month or two or a few weeks.
Yeah.
So
Or a
this
few
is or a few days even in a year like this, exactly. So that's why they go in there maybe 20% of the time. You know, we have it's too much detail for it. We have 7 water year types. We categorize them based on how much water has come out. So only in the 2 wettest water year types are there ever any steelhead up in there. So 5 years out of 7, there's no steelhead up in there. Does that make sense?
Yeah.
And then this shows you I think I gave you guys these.
I have this.
Yeah,
Yeah, I have
that
this
just
one.
shows you that we go through dry and wet cycles. That's rainfall. You know, there's a big variation in rain. And this shows you January of this year. And this was until recently, this was the driest year since 1976. It's probably going to be relatively similar to 1976 right now. And then the other thing I gave you guys with that pie chart is just to show you where does all our water come from. So, or who uses all our water. So the water comes out of the river, 75% from the Carmel, pumped in this area down here, the blue area. And then 25% from here, and this is how it gets used.
Okay. Adrienne, do you have one of these?
Nope.
I only printed one, so
Yeah.
you guys can make a copy.
Yeah.
Yeah.
Or we can just share it.
Yeah.
Um,
Did you have any other questions or?
Is there any other
um,
things that you think we should know?
No, you know, you're that one you guys can keep. I printed that one for you.
and here, like, what does it mean? Age 0 plus.
Okay, so I gotta look at this upside down myself. So they
There's
come.
one over here.
Yeah, the adults come in and spawn, right?
Yeah.
And so that's spawning. Then some of them go back out. That's Celts. That means that they gave up their eggs or their sperm and they bred, but they survived and they went back to the ocean. So then now they have to be in the gravel. That's the intergravel or Alevians. That means they're and that's why you have to. Yeah, I pronounce them Alevins or Elvins. It's different ways of pronouncing it. Both are right, and that's why fish need gravel. They need rocks between like 1.5 to 5 inches, because the eggs are floating in those rocks and the water is flowing through those rocks. So in a river like this that has a lot of sand, we need floods every once in a while to clean out all the sand and open up the rocks. Because what happens if the rock's all clogged with sand? There's no space for the eggs. Yeah. So the females, when they come in and spawn, they make the nest, and that's what they're doing. They're using their bodies like this to stir up the gravel, knock all the sand out, and try and have the clean rocks fall back in the hole.
Our last interview yesterday,
Mm-hmm.
was with Brian Leneef, who's president of Carmel River Steelhead Association. He showed us some pictures of reds and explained that they go dig one hole and then lay eggs in that one, and then do another, and then
To cover them up.
Right.
cover them up.
Correct.
And then just keep going in a line.
Correct. Yeah. And so when they come out, they become fry, which may even have a little yolk sac still attached to them. And then they absorb that yolk sac and they start to swim, and then that's when they're finally, a little 1-inch fish. They're an age 0. That means I haven't completed a whole year of life yet. That's a fisheries biologist term or a scientist term. Now that means I've been in the river for at least 1 year, maybe longer, age 1 plus. Some of those fish go to sea. That's why that arrow you see go to smolt. But most can't. They haven't gotten big enough yet.
So only the if there's like a little not that much that year, they may be bigger and go age 1 or 2.
Right. So like if the guys who are super growers, we don't know why some fish grow faster than others. The guys who are super growers, or if there was enough food for a few, say 10-20% of these guys to get big, they might go out. But most of the time, they won't get big enough in 1 year. So most of the time, it takes until they've been in old fresh water 2 years for them to get big enough to go out. Some even have to wait until they're age 3. But in this river, most of them are age 2. The next most number is age 1 and then age 3. So the majority of fish that go out or have lived in fresh water 2 years. The next most number that go out are 1-year-olds, and then there's a few 3-year-olds. Most don't stay 3 years. And then they become the smolt that you saw. That one right there. That's the smolt. And they go down to the ocean, and like it says, they spend 1 to 3 years in the ocean. So since it takes, most of them are 2 years old in fresh water, and takes at least 1 year living in the ocean, how old is the youngest steelhead that usually comes back? No, 3. 2 plus 1,
2.
right? 2 plus 1.
Okay.
Yeah. So the steelhead that come back are 3 and 4 years old now. some 5 years old. So 3, 4, and 5-year-olds are the majority of steelhead who come back. So that could be 2 years in freshwater, 1 year in the ocean, 2 years, 2 in the ocean, 2 years, 3 in the ocean, or it could be a 4-year-old who was 1 year and stayed 3 years in the ocean. So you see, there's all kinds of combinations.
Wait, could there be a 1 year and then a 1 year?
Yeah, it could be a 1 plus 1, but that we don't see hardly any of those.
Okay.
They just don't get big enough. Because think about it, if you go out as a 1-year-old, are you big?
No.
Yeah, you're pretty small. If you only stayed a year in the ocean to eat, are you big?
No.
No, you're pretty small.
Unless you like find this giant, like swarm of
Oh yeah,
krill.
if there was a big
like
swarm of krill and a whole bunch of anchovies and herring out there and you just ate and got really fat really fast, yeah, you might be back. But mostly, it's 3 years old is the youngest we see, so 1 plus 2 or 2 plus 1.
Wait, so as a Celt, they just sort of gave up spawning?
No, they successfully
Oh,
spawned,
okay.
and then they didn't die though. It didn't stress them so bad that they died, and they go back out and they feed. They think for at least 2 years before they'd come back again, and then they try to spawn again. And nobody knows if they make it out a third or a fourth time, but there've been enough studies done that they know that about 20% to 25% of them make it out to do it one more time.
And are most of the ones that make it back out females?
We don't know that.
Okay.
Don't know that. Matter of fact, they don't even know where steelhead go in the ocean. They have lots of tracking programs for salmon, king salmon, coho salmon, sockeye salmon, because those are important commercial species that, sport fishermen catch them, but commercial fishermen catch them. And they're more abundant. So they've marked and put radio tags and things like that on a lot of them, and they know exactly where they go to feed. They have their migration routes. They know where off the Alaska and the Bering Sea, not the Bering Sea, off Alaska and off the Russian Sea and the Russian Peninsula they go and feed, but they don't know where steelhead go. All they know is that all the regular salmon migrate kind of parallel to the shore off the shelf, the coastal shelf. What they know is the steelhead go way out and then disappear and they don't find them. So they don't know where they're going. They assume that like the rest of the salmon, they're making a run north to feed in the North Pacific Ocean. But they haven't had enough big steelhead with big, satellite telemetry tags on them to know where they go. So we really don't know.
So do they ever try tagging them?
Yeah, we're going to try tagging some here in the next few years if we can get some grant money. Because since we rescue fish on the river, we sometimes rescue fish this big. Most years we only get 1 to 3 of them. But like last year we got 8 or 12 of these. So last year we could have put tags on 8 or 12 big fish and put them out in the ocean and watched where they go. And a gal at a researcher at Hopkins Marine Station, you know where that is in Pacific Grove? Yeah. Her name is Barbara Block, B-L-O-C-K. She does she puts satellite tags on big things: whales, dolphins, turtles, sharks.
Big fish, maybe?
Yeah, she hasn't done big fish yet. She's done everything, but a shark is a fish.
Yeah.
But she's done sharks, she's done tuna, turtles, whales, dolphins.
Rays?
Hasn't done rays because they stay on the bottom. You got to have them come up to get the tag, have a signal. And what was I going to say? Harbor seals and sea lions and walruses and things like that. And we're going to try and work with her to have her tell us what tags to buy. And there's an array that exists off the coast of California now, and she's going to put one more of these floating sensors in Carmel Bay. There's one in Monterey Bay right now. And that way, when our steelhead go out, they'll be picked up at the sensor in Carmel Bay, Monterey Bay, and if they stay close enough to the coast, they'll be able to pick up that tag all the way to Alaska. Then when they're at the surface, it'll get a satellite signal. But these floating arrays can detect them if they're close to shore in shallow water. And so we haven't tagged any yet, but that's the goal, is to tag some big
Why
ones.
does it have to be close to the surface to sense
Think about it, water is thick, right? So it absorbs the signal. So, the farther you are away in water, the harder it is for that signal to get to the receiver.
Okay.
So whereas when the fish is at the surface, nothing, very thin atmospheres fire the radio or the satellite, the GPS frequency, high frequency signal to the satellite very easily. But that signal doesn't travel very far through water.
Or would it travel slower on water? Or?
I don't think it would affect the speed too much, but the term is attenuates, meaning it slows it down. I mean, if you throw a rock through the air, it flies pretty far. You throw a rock in water, it stops. It's that principle. It's a thick substance. So something trying to move through it, or the way sound moves, is it moves this particle, then this particle, then this particle. So the thicker it is, the more energy it takes to do that, and the energy gets used up. And the signal goes and then disappears, whereas in air, it goes a lot longer.
Okay, so, but, Like, I know whales can like make a sound that goes for miles and
Right,
miles. Is
right.
it a stronger sound?
It's a stronger sound. Yeah, they're using their whole lungs and their stomach, and they're a big animal, and they're putting out a lot of energy, and it's a big vibrating drum, their body. So they're displacing, they're putting a big energy surge out over a large volume, and that's why it travels so far. We couldn't produce a tag this big that would generate that much power to generate a signal like that.
Maybe in a few years.
Maybe in the future, yeah.
Yeah, when we get better.
What actually controls signal strength now is mostly not the electronics technology, but the batteries.
Oh.
Because you use power, right? So with all these batteries, all these tags that you put on animals, you have to decide how long you want to track the animal, and what they do is they don't put out a signal constantly. They have every 30 seconds or every 3 minutes or every hour, because the battery will go dead otherwise.
Yeah.
So they put out a pulse signal, not a constant signal. And today lithium batteries are the strongest, longest lasting, smallest batteries. And so I think that they can put a tag on a fish that will send out a signal every 3 minutes, and it'll last about a year. But that's the best they can do right now. And it's a fairly big tag, because the battery's got to be fairly big to last a
Yeah,
year.
it'd be cool if they can get like a water wheel maybe connected to a tag, because a fish is most likely not going to just sit there.
Well, what they've done with some animals that come to the surface a lot, like sea otters and dolphins and sea lions, is they put a little solar panel on it. And temporarily, when it's at the surface, it's charging its own signal battery. I mean, it doesn't make it last forever, but it makes it last longer. So they put like little micro solar panels on tags.
Yeah, they should try putting like a mini water wheel, because this fish is going to be swimming.
Oh, I see what you're saying. So when
And
it's
then
swimming, you
it's
do
gonna
it.
spin it.
Yeah, well, I don't know. Maybe
Like
maybe you can patent that. Because there's a if you guys ever want to go see them, I don't know them. There's actually a group in Marina that makes these tags. They have a local business, and they're in Marina, and they tag all different kinds of animals, and they make these satellite tags and these underwater tags to tag animals. So I will try and get you. Do you have any other questions? Otherwise, I'll try and go print you the map for the watershed that shows the extent of the spawning habitat. Did they get what they need, or more than they need?
A lot.
Water. We pump it over the hill through that route and put it in the ground.
And
in
Delray Oaks, you pump it?
Pump it through Delray Oaks. The pipeline goes through Delray Oaks. I'm trying to see if I have one of the maps I wanted to copy for you guys in here. Nope, I don't.